Hey everyone, my name is Simon. I came from Berlin today, and I've been in the blockchain space for around 3 years. I come from a business and IT background, and I've been focusing a lot on privacy, specifically GDPR. I'm here to kind of talk about machine networks, how to leverage blockchain potentially in the long run for distributed machine learning, for machine networks. So I'm here to present you Xane. That's how it's pronounced, Xane. What do we kind of think? So we think that customers expect from us to provide something with blockchain for which they can be in full control over who has access to the devices and machine data. So imagine yourselves with your phones walking around. You have 26 sensors in your iPhones, for example. Do you own them? Do you get rewarded for producing data for Apple? The same goes for your cars, right? You drive around your cars, and actually all the data goes to your Tesla, to your Mercedes, whatever, right? This is kind of where we need to go to really enable, essentially, for example, autonomous driving. Where do we come from? So Xane was founded last year after having been researched for 3 years in Oxford universities of a team that essentially stress tested different consensus mechanisms, that did mathematical verifications of a Hyperledger, Coda, different blockchains, so to say. And Leibniz and Lundbeck, the CEO of Xane, essentially comes from a cryptographic and, machine learning background, and he played around with different concepts on how to optimize blockchains with machine learning and how these two also interact with each other. So essentially then, almost a bit more than a year ago, Xane was spinned off from the research project into a AG in Berlin, Germany, and since then has done several different pilot projects. 2 of them were one with Daimler, Mercedes, and then manufacturing use case, and the most prominent one was published in February with Porsche, where we first of all tested our machine network, our distributed machine network. So during the last year, essentially, we have been playing around a lot with these different concepts, different learnings that came out of the research projects, and we have implemented them for different pilots. And of course, as many blockchain companies struggle with this when they work with industry partners, is, okay, where do we now put our focus on? Where do we take our next pivot? What do we learn? What do we reflect of what we have done so far? What's possible? What is just a vision? What is just possible in 5 years? So what have we learned, essentially? So we learned that private blockchains do not make sense for a single entity, but only for consortia. For consortia, though, it's very, very difficult to use a blockchain because they have to make business and process decisions across different corporates, across different hierarchies, philosophies. It's very difficult to even find an appointment of decision makers to put onto one table. On the other side, if you really want to put, for example, blockchain nodes into a car, they're still way too immature, way too inefficient. So we need to find a way to truly bring that on machine level. The third aspect is that, of course, the security of public blockchains and the benefits a public blockchain brings are tremendous, but they are also very early stage. We have scaling issues and others. So we still need to figure out a way to then provide this kind of missing fear of compliance and complexity to valid business use cases for enterprise across potentially different industries, across machines. So to address those challenges, we came up with a mission for which we really want to focus on providing currently an intelligent infrastructure for humans, machines, organizations, and their own for device-level security, meaning down to the embedded device themselves. How do we do this? So essentially, we build a flexible access control platform that you could potentially use, for example, to allow your son to drive your Porsche, to allow your postal maid, your DHL, FedEx, whatever, to put a package into your car, but not by a fashion that it's used today, where you send a signal to a centralized servers, verify yourself as who you are, and then potentially get a signal back to open a car, but actually just talking to a car network itself. So this is what we think will truly enable very high flexibilities, a lot of new use cases, and essentially something potentially similar to that Apple iTunes App Store, but just for cars. So you could have a lot of applications that can run on top of a car network, a vehicle network, but also other machines essentially. This is also related to charging. It could be related to quality standards, insurance, and so on. So I hope I'm not going to get too technical now. I will do a bit of a technical deep dive, but I try to just scratch this topic. So essentially, we currently see 3 layers. So the team in Oxford built a new consensus mechanism called proof of kernel work, proof of committee work, which is in the middle, which I will explain in more detail in a second. On top of that, we will have the like a client layer or a node layer, if you want, of essentially devices validating themselves in that vehicle network that was mentioned before. And below you will essentially have that access control layer for data points, for permissions, in order to really be able to essentially also send software updates to those networks, extract information from those networks, but also keep certain informations that are your business secrets for yourself for now. So keep some nodes also on premise. So that first layer essentially is that hybrid client layer, which works in a way in which we see a processing client that is implemented into a, for example, board computer, of what we have done with Porsche, so that you can essentially have very lightweight hybrid client, we would say, that can participate in a consensus mechanism in order to validate transactions, in order to share permissions to different functionalities. On the other side, you will have so-called full nodes, where you store the full transaction history, the full blockchain, in which essentially enterprise can then implement or directly implement compliance. They can directly implement data protection regulations, and they can choose what kind of information or information links to actual data points are stored on that blockchain. This would mean that once you have set up such a client in your enterprise on-premise, you could potentially then say, okay, now I'm going back to a consortial use case that can be within my industry, but also cross industries. And I can just say, okay, I will grant access to specific data that I own for that specific use case and grant that access through that, let's say, through that blockchain mechanisms. This is a very interesting phenomenon because this way you can inherently bring compliance and, let's say, enterprise compliance to industrial blockchain use cases. The second layer is that machine consensus layer, or this energy efficient proof of work. This was essentially created by realizing that many proof of stake, proof of authority, and so on mechanisms do not fully function in the terms of mathematical terms, and hence it was realized that only proof of work is a truly randomized and truly secure, let's say, consensus mechanism. So we should keep that part in the middle, in the committee, in a kernel, as we call it here. So then to really scale that up, we, in the first step, design a committee or like a whitelisted nodes for essentially your cars, your cell phones, or whatsoever, that for each block use a specific cryptographic partitioning function, which will be essentially a randomized amount of nodes is chosen for each block that forms that committee that then does proof of work. So if I'm a node and you guys are nodes, you will not know that in the next mined block you will be in that committee. So each round is basically randomized. This means you will still need a 51% attack on the whole network. But the committee itself can be quite small. So you can have, I don't know, 1 million cars and maybe 20,000 of them conduct a proof of work. But even then, if you scale it up to 2 million cars, you still only need 20,000 to do a proof of work, which makes it very energy efficient. The third part essentially is that access control layer, where you could, for example, use, for what we currently have, smart contracts in order to share different methods, functionalities, different user groups. You could inherently implement specific users or keys, in this case, which relate to the user in the car itself when a car is sold, in the machine when the machine is sold, and potentially then share access to those specific to your use cases. This would enable you to essentially then implement all kinds of different use cases. And we believe that this will be the foundation for future communication protocols for autonomous devices, autonomous machines. Yeah. So just to summarize the technical USPs, essentially we strongly just focus on embedded systems. So we really want to be that layer, that backbone of all kinds of future blockchain and IoT devices that really goes into embedded end-to-end. It's not just a protocol on top or a lightweight wallet, but it's actually right down to the device itself. We will implement, we are implementing a low energy and energy efficient mechanism so that you can really actually use smaller microprocessors, microcontrollers, but also board computers in cars. Through that hybrid client structure where we have the full nodes on-premise, we can really implement a scalable data storage, but we also are interoperable with systems like IPFS, BigChainDB, potentially could use something like Ocean Protocol on top for data marketplaces, for building data marketplaces. So we do try to really bring together the best of those worlds in order to really build a full stack of a distributed business case, I would say. And of course, we really need to be careful with the upcoming data regulations, but also privacy that is utterly important, as we are realizing currently, Facebook scandals, all kind of hacks that are happening. So how do we really make sure that in the long term, if you want to have AIs being part of our all everyday life, we can still be in control of what we call our data privacy, right? Our digital footprint. Essentially, we are currently actually already 30 employees. I would say 20 to 25 of those are engineers. We have an Oxford in Berlin, a small one in Stuttgart with regards to automotives, and a small research team and a development team in Oxford. There you can see Leifnis and Lundbeck, who essentially worked for IBM, Daimler, and others as the head of Zain, essentially. The CEO, Felix, who's also sitting there in the row. He is here today as well. He is also a computer scientist that has worked with Daimler for most of his life. And we have very strong engineers from the automotive sector, but also essentially from very deep roots to OEMs and others. So whom do we work with? Essentially, we really just try to put companies on here that we actually work with. So we are doing projects with the ones in the first row, I would say. We have very strong research partnerships with the second row. And essentially, we really try to always work together with all the other blockchain companies out there that we really value highly. For example, Ocean and BigChainDB. I think that's it already. Thank you very much. I'm open to questions now.
Very much. Are there any questions? I'm looking for the microphone. I think it's here. No microphone? Without, maybe you can repeat the question.
So, the question is, what's in what way your blockchain, if I'm using this, and I have an opportunity to use IOTA or you, why you?
Essentially, we think that we work closely with IOTA, and we think that IOTA is ideal for really the micro payments across those machine networks. But the technology has some challenges when it comes to dynamic networks, when nodes go offline, when cars or machines drive around or move. So IOTA is great if you have a hub, if you have something that we all send data to, and from there you could essentially then collect transactions that you could, let's say, reframe into payments or something like this. Then IOTA makes a lot of sense, but we essentially try to really be the one that can directly be embedded into devices. So this is something you currently or you cannot do with IOTA. Does it make sense? Also, we can, through our access control platform, we can essentially also provide you with, for example, offline access to your cars, offline permissions to your devices, which is also something that you could not do with IOTA. So IOTA would be more of the payment channel, I would say.
They are developing their own, at least last year. They developed their own embedded like hardware plus software.
You mean Weave?
Weave.
Yeah, they're from NBT.
And next big thing, NBT.
Yeah, next big thing.
Yes,
Weave. They're
yes.
called Weave.
Yes, no, yes. I don't know.
Yeah.
It's maybe.
We also we are quite close with them as well.
Yes, and what's the difference between you and them?
We are not trying to build our own hardware. We really try to implement it into, let's say, new production, or we try to be the protocol that can be really implemented to, let's say, in the next 3 years, the new OEMs, all the new microprocessors, car lines, everything, essentially. So I think they are trying to really build a new chip completely, which they implement everything on, and then they try to sell that. So we actually go to the existing ones, right?
Thank you, Simon, for your incredible presentation. Please give him a warm applause.
Thank you.